everyone. This is Peng from Airbnb. Thank you all for coming. Thanks Simon for inviting me here to the talk. It's a great pleasure to give a talk here. So today I'm going to talk about how to build a machine learning pipeline using Airsolve. So Airsolve is an open source machine learning library that was developed on the pricing and availability team at Airbnb. So Airsolve was started to support the pricing modeling task at Airbnb. So therefore, before I dive into Airsolve, I want to spend some time talking about Airbnb pricing. So our team is called Pricing and Availability, also known as the Panda team. So the primary goal for our team is to build tools to support our hosts to help them to set unbeatable price so that they can be more successful in the competitive marketplace. So let's take a look at this demo. So if you're a host on Airbnb, so this is a calendar view you can see on the manage listing page. So basically, instead of setting a flat rate for all the nights, you can set customized daily price. So by smartly setting your daily price, you may be able to get more bookings and get more money. Hotels usually have some professionals who help them to set the price, but most of our Airbnb hosts don't really have the resource to do so in a very optimized way. So that's why they need our help. So the demo here is showing you how the price tips work. So as you can see, basically we provide a price suggestion for every available nights on the host calendar, and then the host can choose to adopt our price tip for one night or multiple nights. So this is great. So this is actually helping the hosts who are using our price tips a lot. But the problem here is that it's very difficult for the host to keep updating their calendar to make sure their price tips are always updated to using our latest price tip. So to fix this problem, so we recently launched something called Smart Pricing. So Smart Pricing basically makes the whole setting price process much easier. So basically, the host only need to set mean price, max price, and hosting frequency. And then once they turn on the Smart Pricing button, their whole calendar will be controlled by our algorithm. So we will always keep their price tip updated using our latest price tip, and also the tip will always be bounded by the mean and max set by the host. So basically, through A/B testing, we found this is helping our host a lot. They're actually getting more nights and earn more money. So the problem here is how do we make sure our price tips are optimal for our host? So this is the main task of the machine learning engineers on the Panda team are working on. So I'll talk a little bit about the pricing model. So the very fundamental problem that we need to solve for pricing modeling is demand prediction. So in particular, we want to predict the booking probability for a particular listing night. So we do this in two steps. First, we build a binary classification model to predict whether a listing night will be booked or not. And then we do calibration. So we estimate the accurate booking probability based on the binary classifier output. So the model we used for building the binary classifier is generalized additive model. So the model is defined in this formula. Here's this x1, 2, k are basically features. So, and each feature corresponds to a function. So that function maps the feature to its weight. And the model output is nothing but the sum of all feature weights. So and then in Airsolve, the generalized additive model can support two types of functions. Spline, which is a piecewise linear function, and then also linear. So feel free to interrupt if you have any question. So if not, I will go on. Okay.
So it always supports piecewise linear, or will it support arbitrary?
It supports piecewise linear.
Okay.
So it's actually arbitrary degree. Piecewise linear actually can model highly nonlinear shape, right?
Well, I'm saying in each interval, would you?
In each interval, we're actually doing linear.
Okay.
But because we have a lot of bins, so it is actually highly nonlinear.
Yep.
So here is some interesting features we learned from the model. So this is a day of year feature for different markets. In this case, we're looking at Sydney and Beijing. So as you can see from the first plot, the feature weight for the summertime in Sydney is very low, and well, for Beijing it's very high. So this means our model actually captures the per market seasonality of the travel trend. So next.
Is it a global model?
It is a global model, but this feature is a market across a day of year feature. So next I'll talk more details about Airsolve. So first, Airsolve is for machine learning, just to have a quick overview of the machine learning problems. So basically, you can consider machine learning model as some function that maps some input to some output. And there are basically 4 key components here. So first is representation. You need to choose what types of function you want to use for your model. Like you can have linear function, decision trees, or in the pricing model case, we're using generalized additive model. And then you need to define some evaluation metric. So for different problems, the metrics are often different. For the pricing binary classification model, we're usually using AUC for evaluation. And then you need to have some optimizer that can help you to learn the specific parameters in the function. So this is often done by minimizing some loss function on your training data. And finally, one additional or optional but very important component is feature engineering. So if you're using like deep neural nets type of model, you may not need feature engineering that much. But for us in Airsolve, we really focus on a very simple interpretable model. Therefore, feature engineering is very important for our problem. So next I will show you how these different components are implemented in Airsolve. Okay, first I want to acknowledge Hector. So Hector is an architect of Airsolve, but unfortunately he left Airbnb a few months ago, so now he's back to Google. So currently Airsolve is mainly maintained by the remaining ML engineers on the Panda team. So thank you, Hector. So Airsolve basically have 2 parts, core and training. So the core part is implemented in Java, and training is in Scala. And in core, we define some models, transforms, and some basic data structures. So in models, we really focuses on interpretable and human debuggable model, which are usually very simple model like linear model and the generalized additive model I introduced earlier. And it is also worth noting that the scoring function in Airsolve is actually also implemented inside the model in Java. So this actually makes it very easy to use the model for real-time scoring. So the second part is transforms. So this is for feature engineering. So Airsolve provided a very powerful feature transformation language for the users. So it allows the user to do very sophisticated feature transformation without actually writing any code. They just need to write the config files. And also there are data structures. Those are all defined by Swift. Okay, so the second part is training. So in training, we implement a trainer, evaluation, and something called a generic pipeline. So currently in Airsolve, we are only supporting supervised learning. And our training code runs on Spark. Therefore, it allows you to train your a model on a huge amount of data in a distributed way. And for pipeline, so generic pipeline basically is just a template of a set of tasks. So with generic pipeline, so our data scientists can train, evaluate, and debug their model without writing any Java or Scala code. They just need to write config file. That's the idea. So any question? Okay. So next I want to talk about why we are focusing on interpretable and human debuggable model in Airsoft. So first, when we started the pricing group, our pricing group is actually pretty new. So I joined Airbnb in March 2015. So the team was about maybe 2 months old at that time. So we don't really have existing training data. So the data is new, not fully defined. Therefore, we need some tool to help us to understand the data better. And second, our features are mostly sparse and interpretable features. So by interpretable, I mean those features actually have its meaning, like the number of rooms, location, room type, or price. So every feature has its own meaning. It's not like in computer vision, we may have some image pixel as a feature. So the pixel itself, by itself does not really make any sense. It's not, so we call that type of feature as non-interpretable feature. And also, a debugger model can help us to debug our data because we often have some data quality problem, and also this can also help us to discover something like label leaking. So yeah, we had some label leaking problem when we first trained the model. And finally, with this type of model, we can discover some relationships between different variables and our target prediction. This can help us to get some business insight. Like, for example, we can say how different types of amenities like parking, Wi-Fi, or reviews are affecting the booking probability for a listing. So next I want to show a demo. So this demo will show you how we're doing feature debugging. Okay, so this is a internal tool we built for Airsoft model debugging. So I'm loading actually a model I recently trained. It's a toy model. It's not the actual pricing model. But there are some simple features I can show you here. So as you can see the most important feature here is review. So the more review you have, the more likely your listing will be booked. And then there is a day of year feature. So this is now crossed by market. Therefore, it is already reflecting the global trend. As you can see here, like overall for Airbnb, summer is a high season. And then there are the price feature where the lower the price, the more likely you will be booked. So yeah, you can also solve the feature by playing with a why-was thing. So in this way, because we often have hundreds of thousands of features, by having a tool like this, it's easy for us to debug feature, to identify the most important features. So let me show another feature. So this is some cross feature. Okay. So from here, you can find something very interesting here. Let me first sort by the weight.
I have a question.
Mm-hmm.
What is the y-axis?
So the y-axis is weight. The x-axis is the feature value. So this is a spline. So this is how the feature value is mapped to the feature weight. So after I do the sorting, so I can identify the most important features here. So as you can see here, private room cross price feature, it looks like this feature is more important than the entire room cross price feature. So this means for Airbnb guests, they are more price sensitive when they are trying to book a private room. They are less sensitive to price when they are trying to book an entire place. Okay, so this is the tool we're using for model debugging. Okay, so next I'll go back to the talk. So, why do you want to use Airsolve? If you have a problem that is similar to our pricing problem, like you want an interpretable model and you have sparse and interpretable feature, you may want to try Airsolve. So a second motivation for you may be, so if you have some modeling task that is really like feature engineering heavy, you may want to consider use the feature transformation in Airsolve because it provides you a way to control the features by writing some simple config files. So sometimes maybe you don't want to use the model in Airsolve, but you can still use the feature transformation part in Airsolve to help you to do feature engineering. And yeah, and because the transformation are defined by config file and implemented in Java, so this makes sure the consistency between training and scoring. So another motivation might be distributed training on Spark. With this, you can train on a huge amount of data. So another advantage of Airsolve is it's very easy to use it for real-time scoring. So because, as you can see, the model scoring and feature transformation code are all in Java, so there's no Spark dependency. And basically, the models trained on Spark can be directly loaded in a Java service for the real-time scoring. Airsolve is really good at like the thing we're trying to optimize for, basically, but it's not designed as a generic solution for all machine learning problems. Here are some cases where you may not want to use Airsolve. For example, you have a really small training data. You can fit all your data in a single machine, and you don't care about real-time scoring. So in this case, I feel you may be able to iterate faster by just using like scikit-learn or R. And second, if you're doing like image classification or speech recognition type of problem, so you may not want to use Airsolve because your features are actually not human interpretable feature. I think in that case, you should just try out the cutting-edge deep learning thing. Yeah. So next, I will introduce the underlying feature representation in Airsolve. This is an ingredient that is making Airsolve really flexible for feature engineering. So feature vector is basically corresponding to one training sample. So if you are familiar with other machine learning library, it is just the feature vector is just one row in your training sample. So there are three types of features. Those are all defined by map. So the key of the map is feature family name. So feature family is like a very unique concept in Airsolve. It is basically a set of features with the same type. So organizing related features into the same family makes it really easy to apply operations on a group of features. So so it's worth noting you should not put features with different types in the same family. So let's take a look at an example of a feature vector that is representing Airbnb listing. So for the string features, we have two feature families, location and listing. So location maps to a set of strings, like San Francisco, CA, USA, and listing maps to a set of strings that are representing the listing properties. And in float features, we have three families. The first is location. So this maps to another map. So the key of the internal map is the feature name. And in the location case, we're looking at two features, latitude and longitude. So you may notice that there is a feature family called label. So this is actually the label for your training sample. So in this case, this is a positive sample. So you should never use label as a family name for other features. And then for dense feature, so like you can imagine that, so we may have some image quality feature to representing the to describe the listing quality. So for example, in a dense feature, the feature family will map to a list of double, so it's a dense feature. In this case, we have image histogram or an RGB feature. Any questions? Okay, so that's feature vector. So additionally, Aircel provides a way to organize different feature vectors into an example. So an example consists of a list of feature vector and a context feature vector. So the context feature vector are features that are in common over the whole group. So for example, you can maybe put all the feature vector representing listings from the same Airbnb host into one example. And you can put the features that are in common for this listing, like the host feature, into the context. So that will be shared among this group. And of course, if you want to treat each training sample independently, you can just put one feature vector in this example. So that's the feature representation part. So next I will describe feature transformation. So Aircel feature transformations are always operating on feature families. So it can be applied to one feature family or two different feature families. For the first situation, imagine that you may want to apply some element mice function to a group of features. For example, you want to do some normalization for some feature in one group. And then you can output those features to a new feature family, or you can choose to override the original feature. So in the second case, we can apply transform to two feature families. This will generate the cross features from two families to capture some feature interaction. So here are some examples. So in the first example, let's take a look at the string cross float feature. So this allows interactions between string features and the float features. In the pricing model, we have a feature which is a market cross price feature. So that feature is generated by this type of feature transformation. So the red text here are the config file you need to write to apply this transformation. So basically, you define the transform name, which is string cross float first. And then here, the field 1 is a feature family name for the family that consists of the market feature. And then this field 2 specifies the floating feature family that consists of the price feature. And then the cross feature is output to a new feature family called M cross F. So, and this is how we are modeling the per market price information. The second example is multi-scale grid quantize. So this is used to construct multiple nested grids for 2D coordinates. This is very useful for modeling location. So we also use this in our pricing model. So in this case, the transform name is multi-scale grid quantize. And this transform applies on the feature family called LOC, it's basically location. And the two features we're operating on are latitude and longitude. Those are specified in value 1 and value 2. And the bar case defines the bar case size we want to use to do the quantization. And then those quantized features are output to a new feature family called QLOC. Okay, so once you define those in config, it's very easy to apply those transforms to example. So basically, you just need 2 lines of code. So the first line defines the transformer. So as you can see, the transformer actually is loading the config file. And in the second line, you apply combine context and item to your example. Example is the example I introduced earlier. So in particular, there are 3 types of transforms. context transform, item transform, and combined transform. So for this is an example in Airsolve. Here we have context and some independent item. So in the transformation, we will first apply the context transform, and then we apply item transform. And then internally, Airsolve will copy the transformed context to each transformed item, and then we apply combined transform to get the final transformed features. Okay, that's the transformation. Next, I will talk briefly about model. So all the Airsolve models are extending the abstract model. So basically, in the model, we define model weights. So model weights basically are like the parameters in your model. It can be like out array or map. So if you have a forest model, you may have trees. And here we also define the scoring function. So for different purposes, we have different scoring functions, like score item for multi-class, and score probability. We also provided some debugging utility functions in this model. It will help you to do model debugging. And of course, we have loading and saving model weights functions. So if you look at Airsolve, there are actually many models inside, but those are the 4 models that are actually used in production at Airbnb. Each of them are serving different purposes. We support regression, binary classification, and multi-class classification. So in particular, I want to say these are the 2 mostly used models inside Airbnb. So first, the additive model, I would say this is the most reliable model since it has been used extensively by the pricing team. But it does not support multi-class classification. And also, it actually requires a lot of feature engineering to achieve good performance. So another model is forest model. Forest model is not really a very human interpretable model. So the reason we are adding this model is basically some other teams at Airbnb are requesting this feature, so we add this. So the advantage is that it does not require heavy feature engineering. But the problem is, so the current trainer implementation is not so good. So it's actually extremely slow to use this model. Also, if you have the patience to wait, it can also give you really good model performance. So finally, I will talk about pipeline. So this is a typical machine learning pipeline at Airbnb. So like the first step is like we load data from Hive or some CSV file. So for the pricing problem, we're saving all features in Hive. And then we convert those features to example, and then we apply transforms defined by the user in the config file to get transformed features. And then we train the model, and then we do model evaluation and debugging. We repeat these steps for several times. Then maybe at some point we can achieve a reasonably good model. And then how do we use this model? There are actually 2 different ways. So you can use this model offline. You can just run your model scoring offline on your cluster, and then you upload your model output to some online storage, like we often use Elasticsearch and HFile. And then the scoring service can just query those like online storage to get your model score. So another way is like using the model for real-time scoring. So what we do is we upload the model to S3, and that will be loaded by the scoring service to do real-time scoring. So why do we want to do real-time scoring? So for the pricing case, actually most of our modeling scoring job are running offline. But there are some situations that we want to do online scoring. For example, when we have new listings, we don't have any previous information about this listing. The listing information does not even exist in the Hive table we have. So that's why we want to do online scoring in this situation. In Airsoft, we have something called a generic pipeline. So basically, it defines a set of common tasks for building a machine learning pipeline. So it allows the user to train, evaluate, and debug Airsoft model by just writing config files. And this is a link to the hackpad, so you can see detailed instructions on how to build our pipeline using generic pipeline in this hackpad. Okay, so finally, I will spend some time talking about the current status of Airsoft at Airbnb. So for the development, it was mostly supported by ML engineers on the Panda team. It is actually under very active development, but because we are not like machine learning infrastructure team, we are a product team. So most of our development are driven by the pricing modeling need. So this may be very different compared to the development of other ML library. And also, although this project started at pricing, it was actually used by many different teams at Airbnb, like booking teams or race teams or like product excellence, business travel. So it was used. It was quite popular. This is mostly because we have a common scoring service to support Airsoft model. So what does this mean? It means a data scientist can deploy their model very easily without writing any Java code. So previously, data scientists also often have to find some engineers to help them to deploy the model. But with this common scoring service, so it makes their life really easy. Okay, so that's all. Here are all the main contributors for Airsoft. So, and then, yeah, thank you everyone for coming to the talk. That's all from me. So, will you have any questions?
So you showed the feature exploration tool in the beginning. Is it publicly available as well?
It's not. It's actually implemented in Shiny. It's a Shiny dashboard.
It's a what dashboard?
R Shiny dashboard. Yeah.
Please repeat the question from the video. When there's a question, please repeat it.
Oh, repeat the question for video. Okay. So the question is, does the demo, the tool I showed in the demo, open source? Right. So the answer is it's not. It's an internal tool, and it is implemented in using R as it's a Shiny dashboard.
So another question is, do you build separate models for say different cities? And if so, does the tool allow to do so? Basically, have a separate model for Beijing versus San Francisco, right?
Yeah, we don't do that. We have only one global model, but our model takes a lot of features, like hundreds of thousands of features.
Right. And okay, so in terms of features, when you have categorical features, do you map them to binary when you're actually pushing them down?
Yeah. The question is, when you have categorical feature, do you map it to binary feature? So the answer is we're doing something like mathematically equivalent, but we don't do that. As I introduced earlier, we're organizing all the features into a map. So the categorical feature will be corresponding to string features. It will be a set of strings internally in Airsoft. So, but mathematically, it is the same as one-hot encoding.
Correct.
Yeah.
Can you talk a little bit about the training data? What are actually the prices that you train on?
The question is, what are the price I train on? So, the price is not a label. Here, what the model is doing is to predict whether a listing will be booked or not. So price is a feature in the model. The price will be whatever the price the host have set for that particular night.
Got it, thanks.
Do you guys have any metrics on how your model has helped the host to actually get more cookies?
So the question is, do we have any metrics to show that how the model is actually helping the host to get more bookings? The answer is yes, because we do A/B testing. So we know that by using this, the hosts are actually have more bookings. But I'm sure that our model can be improved further. So it's better than the price set by the host. Yeah.
So do you do the opposite, basically try to predict the best price for a given apartment?
So
does this tool allow you to do that?
Yeah, so the question is, do we ever try to predict the best price? The question is yes or no, because we don't know the best price, right? So we don't know the optimal price. We know what price the host have the listing are booked, but that does not mean that the booking price is equivalent to optimal price. So we don't. But
so my question originally was, you said that basically for a given price you output the probability that the place will get booked, right? And where the price is a feature.
Yes.
So is it possible to basically tweak the system to do the opposite when I give the desired probability of being booked as a feature and get the corresponding price as an output?
Yeah, so the question is, can we do the reverse engineering to output the optimal price given a booking probability? So the thing is, how do you define the booking probability? So usually, if 100% booking, that means your price is usually just 0. So the goal is to optimize not just for booking probability, but also for the revenue.
Expected value.
Yeah.
Right? So is it possible to do so with the existing tool or further tweaking and hacking this requirement? That's the question.
We do something like that. This basically makes revenue strategy, but we're not doing exactly the same that thing, but we're trying to balance a few things.
So I have a question. So since we know the demand is always a fix, someone will get their room being booked, someone won't. So if everyone uses smart, so it's still then break this balance. I mean, you know what I mean. So it's kind of you always cannot help everyone to get their home booked. Okay. Based on how many people use. Maybe some people, like early people who adopt this system will be benefits a lot. But once more and more people use this system, how do you find the best price for them?
Yeah, so the question is, if this is applied, if only a small set of hosts are using this is helping them to get more booking. But if all the hosts are starting to use this, how do we make sure they're getting booking? The question is, the answer is we are actually not only competing inside Airbnb, right? So we're also competing with other alternatives. So, but you bring up a really good point. So there are actually, we observe some cannibalization effect. That's why the A/B testing is really difficult to measure the real impact. So say we see 2% gain on nights. So in reality, it may not be that huge because of the cannibalization effect. The bookings that usually goes to the control groups goes into the treatment groups. So that will exaggerate the gain we have. But we don't have really good solution for how to measure the cannibalization effect.
Thank you.
Here, did you find that people who use the tool tend to lower the price or increase the price for their booking?
So the question is, do I find the hosts who are using the tool tend to lower price or increase their price, right? So the question is lowering the price. Yeah. So, so oftentimes hosts are thinking our prices are too low, but in reality, from our A/B testing result, when they lower the price, they get more nights, and at the same time, they also get more revenue, because by lowering the price a little bit, they get more bookings, so overall the revenue add up. Yeah.
So you showed a correlation between the feature graphs that you showed, that when the demand is
high, then there are more bookings. When the price is low, then there are more bookings. But when the demand is high, if the supply is limited, so even a high price, so how do you really optimize the price in a high season versus a low season? Low season is easier because during the low season the prices will be lower. But how do you in a high season ensure that the host gets the maximum possible price?
Yeah, that's a good question. The answer is we also have demand the supply information as features. So we know the demand, we also know the supply. Yeah.
So those two features.
Yeah, the two types of features are out there. Yeah.
Yeah, so do you give customers any insights into the feature weights? So if I have a listing, where should I invest? Should I get a bigger bed? Should I paint the room red? Should I?
Oh, yeah.
Right? What should I do to get my price to increase?
Interesting. We're actually thinking about this thing, but we're not doing this. But I think it's a possible action item for our team. So for example, we discovered something very interesting from our model. Basically, we found listings with a red pillow often have higher booking probabilities because it is having higher people that is more attractive. I guess I don't know. So it is some mysterious thing we learned in the model.
Yeah, I was going to say I do use the tool, by the way.
Oh, thank you.
And I will buy a red pillow.
So in terms of
Yeah.
Can you elaborate more about how you use Spark to train your model? Is it going to be what's going to be the RDD, what it can cache, how you actually model?
How do we? So basically, so I can talk a little bit about the additive model. So basically, our data are loaded from Hive. That's already in RDD, right? So and then we do map partition, and those are data mapped to different partitions, and then we train different the different models on different partition, and then we do some aggregation. So that's how the additive model is trained. It's like a bagging algorithm.
Okay. So in terms of features, right? So you mentioned the red pillow, right? The red pillow is obviously not part of the amenities that are on the selector on the Airbnb, right? So how do you actually extract these features? Is it I don't know, natural language processing from the posting or something like that?
So actually, we have an image quality model. That is an additional model. So that model output is the input to our pricing model. So that model actually captures that information because we found that image quality feature have positive correlation with the booking probability, and the red pillow also this is something we just identified by human eyes, not something.
Alright, but then going back, do you actually parse out the text and the text of the reviews, the text of posting to extract features, or do you just limit to whatever features you have in the general description that are basically selectors?
So we're always adding new features. I think we may be adding this type of text features later. So our model develop cycle is pretty fast. We iterate very fast. So every time we will add some new features or drop some bad features.
The question that I'm asking, for example, the problem that I have, right? I have categorical features which have hundreds and hundreds and hundreds of categories, right? And so, I mean, if I dump these features into this system, right? How is it gonna? What is your intuition? How is it gonna perform, right?
It should be okay because we also have a lot of this type of feature like market. You imagine there are thousands of market in the world, and we also do the multi-skill quantization. We quantize the latitude, the longitude into different markets. All those are a categorical feature. Okay. So the model can automatically capture which features are important. So the model training actually will drop some less important feature by themselves, by the model itself.
You do a global model with one additive model, right? And then you basically dump all these features in it, and that's it.
Yeah, that's it. Yeah.
Excellent.
Thanks. Okay.
If you have like spikes in demand, like the Super Bowl, is your model able to deal with that kind of thing?
Yeah, we don't really. I think we can deal with that thing because we know how many how many views the listing is getting. So for an event like that, so the listing views must be also spiking. Yeah. So.
So you did the demo of the feature and weight challenge based on the hierarchy model because I guess they are more inflated and explainable. Did you see the same trend when you used different model like forest model? Did you see that kind of chart?
So we don't see that type of chart for forest model. The answer is we don't use forest model for pricing problem.
Oh, I see.
Yeah, so what we have observed is that if we do really heavy feature engineering, additive model is often performs the best. We actually tried the like XGBoost stuff to like improve the model, but it turns out the original or additive model is like unbeatable so far.
So I was kind of going back on the supply question. Did you guys investigate, I guess, not just using the piecewise linear, but using natural cubic splines per se? And that's one traditional
Yeah,
question.
so that's a good question. The question is, do we actually use the natural like cubic spline? The answer is yes, because sometimes when we found the spline is actually looking like a cubic spline, we actually do some smoothing to make it actually matching the cubic spline. Yeah. Okay.
So are these smoothings and transformations part of your transformation routines?
So smoothing is a part of the trainer. The training is doing that. Yeah. Okay.
So I have a question about the implementation. So there's also a Spark.ml package that you can build a pipeline and this transformation evaluation things. So is your Aerosoft completely independent of that package, or do you also leverage some of the features there?
So, the question is like.
I mean, there's an existing package called Spark.ml.
Yeah. So, I think when we started this project, that one does not exist.
Yeah, I can also answer that. It's hard to do real-time with SparkML, so
Yeah.
Aerosol does both batch and real-time. And because SparkML is based on data frames, then you can only do batch. It's very hard to take that representation and then apply it in real-time.
Okay, cool. Thank you.
Yeah. Thanks. Okay. Yeah. So no questions. Thank you.